All right, welcome to the session on Azure Cosmos DB with web apps and Node.js with TypeScript. Let me share my PowerPoint and we will start the presentation. All right, so this is the presentation, Cosmos DB, Node.js, and TypeScript. This is me, Chris Joakim. I work for Microsoft. I'm an Azure Cosmos DB Global Black Belt. And this is the outline of this presentation. First, I'll talk a little bit about myself. We'll introduce Azure Cosmos DB. We'll talk about Cosmos DB with JavaScript and TypeScript regarding the software development kit. We'll talk about what TypeScript is and why use it. We'll talk about the azu.js package at NPM. It's a helper that I wrote. And the primary focus of the presentation is this web application that is built with TypeScript and the Express web framework and that uses Cosmos DB. Walk through the code and do a demonstration. All right. So first, let me just talk about myself for a few minutes. And this will be helpful in understanding, why we have this solution, why I built this solution. So I work for Microsoft. I'm an Azure Cosmos DB Global Black Belt. Been doing this role since 2021. I joined Microsoft in 2016 as a cloud solution architect. I have a very long development history. I started in IT in 1986 as a software developer. I've been a CTO. I've been the owner of a consulting company, so I have quite a bit of experience. Languages is kind of interesting. So way back when I started with the COBOL, transitioned to Smalltalk, object-oriented language, Java, many years. Ruby on Rails, quite interesting. Node.js with the mean stack. That was interesting too. Python and TypeScript. There's been many other languages, but those are the primary ones. Now, I also work with CoffeeScript. I'll talk about that shortly. Databases. I've worked with many databases. IMSDB, it's a hierarchical mainframe database. I've worked with many relational databases. Worked with MongoDB, that's highlighted. I'll talk about CoffeeScript and Mongo shortly. So in short, I really like dynamic languages that are with schemaless JSON-based NoSQL databases. I live in the Charlotte, North Carolina area, Davidson. Here is my LinkedIn profile. Here is my GitHub page. I write quite a bit of code, multiple languages, so please take a look at that. You might find some interesting samples. All right, so why did I highlight CoffeeScript and Mongo and Cosmos above? So along the way, when I was using Ruby on Rails, I started using an authoring syntax, a JavaScript authoring syntax called CoffeeScript. So why did CoffeeScript exist? Well, CoffeeScript existed, much like TypeScript exists, is that JavaScript alone can be a bit awkward. It's very easy to make type errors. It's made it very easy to make syntax errors. In my opinion, just doesn't scale well for a large project. So CoffeeScript was an earlier attempt to provide a better authoring language, bettering authoring language for JavaScript. Okay, so why did I call it Mongo here? So this was really a turning point in my career. Sometime in 2008, I believe MongoDB just came out in 2007. So I was working at a relatively small startup, and we had this problematic use case. We were using Ruby on Rails with MySQL, and it just had performance issues. So my teammate and I decided to look at this new thing called MongoDB, and we adopted it. We tested it, we adopted it, and for that functionality that we were implementing in MySQL, our implementation in Mongo turned out to be 50 times faster. 50 times faster. So that was kind of a real turning point in my career in that the solution was faster and simpler. and in short, better. So these are two significant events in my career that have kind of led me to where I am here with TypeScript and Cosmos DB. So Cosmos DB, of course, is the Microsoft NoSQL database. MongoDB is yet another company. All right. So let's talk about what is Cosmos DB. So it's not one thing. It is several. So it's basically a cloud native family of NoSQL databases. So cloud native. So Cosmos DB was never like an on-prem database. It has always run in Azure. It always, was quote unquote cloud native from day one. A built-in geo-replication across Azure regions, built-in amazingly fast single-digit millisecond query performance, always highly available. Single region is 4 nines of availability. Multi-region is 5 nines, so 99.999% guaranteed SLA. So it's really pretty amazing. The primary API is called the NoSQL API. We also have a Mongo API. We have Mongo vCore. That's a new product. Cassandra Managed Instance, and Gremlin. But the presentation today is going to talk about the NoSQL API. Pardon me. My mouse is sensitive. Right. So the NoSQL API stores its content as JSON documents. But the really interesting thing is that it uses the SQL query syntax for querying that database. So therefore, it's very approachable for new developers because virtually everybody in our field knows SQL. So we didn't really need to invent a new query language. And so the really nice thing about Cosmos DB and say TypeScript is that it enables quote unquote end-to-end JSON applications, such that the backend data store stores the data in JSON. So when the web application reads it, there's no need to transform it into JSON documents to send to the client because it already is JSON. Cosmos DB has some really interesting features. These are just two of them. But one of them is called the change feed, and that's for event-driven apps. So what you can do is, as you're adding or updating data in Cosmos DB, you can optionally observe the stream of events coming out of that container, and that's called the change feed. Typically, you consume it with an Azure function, a serverless Azure function. Pardon me. Yeah, so typically you consume it with an Azure function. Another interesting integration is called Synapse Link, and that implements the HTAP pattern, hybrid transactional analytic processing. It's a concept invented by Gartner and Forrester Research, and that is such that your Cosmos DB data is available in Cosmos, but it also flows into this low-cost data store called the Analytic Data Store. Think of it as a data lake, and that's available for analytics and batch processing. And there's a total performance isolation so that you can process this analytic data store with zero impact to your live Cosmos DB. Here's a link to Cosmos DB documentation. There's quite a bit of topics there that I think you'll find interesting. All right. So what does it look like in Azure Portal? So this is just a screenshot of my Cosmos DB NoSQL database account in Azure Portal. This is my account name. On the left nav, you have various functionality. I happen to be in the Data Explorer view right here. It gives a list of my, within the account, the list of databases. So one is called dev. Within the dev database, there are several containers. One of them is called baseball players. I happen to be showing right now the list of items or documents that are in that container. And here is the list of them. I happen to have, this is a container of baseball players. And so I happen to be showing Hank Aaron. If you're familiar with Hank Aaron, he was a prolific home run hitter. But the data, as you'll see here in the right panel, is JSON, right? So Cosmos DB stores JSON documents. Now, I will call out that when you, let's go to the next page, I should define it. When you create a container, you need to define a partition key for the container. I guess that'll be the next slide. So in this slide, it talks about scale. So one thing that's really nice about Cosmos DB is that it's not like a fixed size. It can grow, it can right size, essentially right size to whatever you need. So you can start with a very small application, or it can scale to an incredibly huge application that processes literally millions of operations per second. And how we do that is via the concept of request units. So when you basically you can provision throughputs at either the database or the container level. I'm showing the container level here. So for example, this container, baseball players, has an allocated throughput of 4,000 RUs. That's 4,000 RUs per second of throughput. Now it's auto scale, so it will scale down to down to as low as 1/10, right? So this will auto scale between 400 and 4,000 RUs. So this is a really nice feature with Cosmos, so that you're not going to overpay. It's going to right size itself based on your needs. Right. The next page. So this is the scale tab. Next is settings. So this is the settings tab in Cosmos DB. So another interesting bit of functionality is time to live. So you can have documents expire in Cosmos DB. You can have a default time to live in a container, and individual documents can override that time to live. So that's pretty interesting. We have some geospatial functionality. The analytic time to live. So in addition to enabling the Synapse link functionality that I just mentioned earlier, the HTAP, the data in the analytic data store, furthermore, can also have a time to live. So both the live database and the analytic data store can have a time to live parameter. This is a very important concept of partition key. So every container that you create in Cosmos DB needs to have a partition key attribute defined. And that means that each document will have that populated, and Cosmos DB will use that value to horizontally partition that data across one or more physical partitions. Again, Cosmos DB is a horizontally partitioned database. It might start out with, say, one set of nodes, and we call it a physical partition, but ultimately it could scale, much wider than that. And the partition key attribute is used to do that. All right, indexing is another really super interesting thing about Cosmos DB. So you can define indexes in this JSON syntax here. And what the default indexing policy is actually to include everything. So basically in the included paths, this syntax means essentially include everything except for the excluded paths. So there's a system generated attribute called etag for concurrency control. But yeah, believe it or not, the default behavior is to index everything, even nested attributes. And that sounds like it might not be performant, but it actually is a very fair and commonly used approach, and the performance is actually quite good. Additionally, you can choose to exclude certain paths in your documents, right? So if you know that you're never going to query some attributes or some paths in your documents, then you can certainly exclude them. That will make Cosmos DB index creation that much faster. All right. So this is the interesting part. So Cosmos is a NoSQL database. You store the data as JSON down here. However, you query it with SQL, right? So if you're coming from a relational background, this select statement, should look pretty familiar. So we're going to select the entire document from C, where C is the container, where the container player ID, and again, player ID in this case is the partition key, where the player ID is Hank Aaron. And indeed, we found Hank Aaron. Yeah, so this SQL syntax makes Cosmos very approachable. All right, let's move on. And now let's talk about the SDKs for Cosmos DB. So there are multiple SDKs for Cosmos, one in each programming language, right? So certainly we have a .NET, C# SDK, a Java SDK, Python, and JavaScript / TypeScript. I believe we also have Ruby. So there's several languages. Um, Pardon me. I inadvertently click my mouse sometimes. So the Cosmos DB JavaScript SDK is part of the larger Azure JavaScript SDK. So in this first link here, this is the all of the SDK. So you might get blob storage and web apps, etc. In addition to Cosmos DB in this first link. The second link has points to the actual Cosmos DB SDK. That library, that SDK is hosted here at npm, npmjs.com. It has the package name Azure Cosmos. So the latest version is version 4.0 of the SDK. It adds some really nice features. We have a concept called throughput control, so that one client can't consume like all of the request units in Cosmos. It can be allocated a certain percentage or a certain maximum number of RUs. We have hierarchical partition keys now. That's an optional functionality where instead of a single partition key attribute, you can have up to 3 now. And last but not least, so this is really great, is the SDK now supports asynchronous programming. It's significantly faster than blocking code originally. That asynchronous functionality uses the JavaScript await and async keywords. I believe that's similar to C#.NET. When you install the SDK, you simply run npm install at Azure/Cosmos. Here are some other links regarding the SDK. So there's some samples here, so you might find that interesting. And so the SDK itself, that is this page. So I just chose a random page in the SDK. So we are working to enhance the documentation and to provide better samples, as indicated here in the previous page. There are links to samples. It's not complete, right? So I found myself kind of looking through the source code to find how to actually do things in some cases. All right, so let's switch on to TypeScript. So, what is TypeScript and why use it? So TypeScript is an alternative authoring syntax for creating JavaScript. And basically it allows you to program with types, much like a static programming language like Java or C#, where you use specific data types, and the compiler will check those for you to make sure that you don't, say, assign an integer to a string and vice versa. So it supports typing. You get to define your own types. And the great thing is that the types are checked at compile time, right? But the compiled code does not flow into the actual runtime environment, and I'll explain that a little bit further. This screenshot is coming straight from the TypeScript page here, typescriptlang.org. And so this is just a great example of why you need TypeScript. So in this code, looks like they're creating this object with first name, last name, and role, and then they try to log out this user.name, but of course name does not exist, right? Name is not one of the attributes here. So this simple log statement, creates an error. So TypeScript, basically solves this by letting you know during compile time that this would cause a runtime error, right? So you become aware of your typing issues in the development environment instead of at runtime, right? So it's obviously better to find this out during development rather than production. And with dynamic languages, I'm a huge fan of dynamic languages. I did a lot of years of Ruby, as indicated. I did Python. I love Python, and I love JavaScript really. But they're all so dynamic that it's so easy to make these typing errors where you think you're dealing with a string, but it's an integer, and you invoke string methods on an integer, and the program crashes, right? So it's much better to use a typing syntax to catch those errors sooner. Oh, and sorry, let me back up a little bit. So so there's a personal comment is that um, armed with this with the TypeScript compiler, I found that my velocity for writing code is so much faster because I don't have to like go back to other files and say, gosh, what is this variable? What is first name? Is it a string? Is it what is role? Is it an integer? Right? I don't waste any time doing that. It's all immediately apparent in my code editor. All right, so let's talk about the life cycle here. So basically, you author your code with in TypeScript, and your file types is a .ts for TypeScript, and then you transpile the code, right? So when you install TypeScript, there's a program called TSC. That's a TypeScript compiler, TSC. And basically, what that does, it simply takes the TypeScript, checks the types, right? It doesn't compile, it transpiles the code, checks the types, and then the output is just plain old JavaScript, right? So it doesn't produce like an exe or binary code. It translates from one language into another. As indicated, it'll catch many coding errors, up front during development, not deployment. There's just great IDE support for TypeScript. I will call out Visual Studio Code. It's a free software editor you can download. It has amazingly great support for TypeScript, but there's others. I use the JetBrains tools. WebStorm is particularly good for TypeScript. Basically, many IDEs have great support for TypeScript. Now, if you haven't also, beg your pardon, if you haven't also used GitHub Copilot, this will be very amazing to you once you first start to use it. Basically, you can kind of hook up your IDE, in this case, Visual Studio Code, to GitHub Copilot, and it will, it can essentially write much of the code that you would otherwise type, and it does in quite a high quality manner. I found that my both my code quality and my productivity has probably doubled at least since starting Visual Studio Code and GitHub Copilot. So I think you'll probably find a similar ratio for yourself. So that's development. You transpile your TypeScript into JavaScript. Now at deployment, you're simply deploying the transpiled JavaScript, right? So that's pretty interesting. Node.js is a really great runtime environment. It starts up really fast. It's very performant. Sorry for my inadvertent scrolling. It's great for creating Docker containerized applications and microservices. In Azure, we have many options for many PaaS services for deploying containerized applications. Azure Kubernetes, Azure Container Instances, Azure Functions, Container Apps, and the list goes on. So quite a few. All right, so some just a little bit more about TypeScript. So TypeScript is an open source project. It was created and is developed by Microsoft, open source. So here's the link to the documentation. Again, the type safety enables very high productivity. There's a couple surveys here mentioned that it looks like much of the JavaScript community is starting to adopt TypeScript. Looks like 93% say that they would use it again. So, the initial, this is saying that the initial experience that developers have with TypeScript is a positive one. And it's apparently a very loved programming language. Looks like Rust might be number one, TypeScript 2, Python 3. From personal experience, frankly, I wasn't particularly fond of JavaScript, but TypeScript has become like my preferred language. Python is second. Okay, let's move on. So the next question is, okay, great. What does TypeScript look like? So here's a real brief example, and here's some items of note. So, it has the familiar import and export statements, right? So when you create a module or a file, you can choose to import certain classes and things, and you can likewise export them. Classes, right? So we see the class keyword here. So, much like in Java or .NET or even Python, you would create, a class-based application. The class can have a constructor, can have methods. Now, this is the typing part, right? So this part here, the SQL, this is saying that there's a variable passed into this method called SQL. It's of type string. Additionally, there's an optional parameter as denoted by the question mark, and it's a string array, right? So it is enforcing those types during the TSC compilation process. Furthermore, this method is saying that it returns an instance of SQL query spec. Now, this is a real subtle thing about TypeScript. So it has the concept of interfaces, right? And so as you see, this class does not implement this interface. So TypeScript interfaces are kind of like duck typing, where if it looks like a duck and quacks like a duck, it is a duck. So likewise, the interfaces in TypeScript is that basically this SQL query spec, I believe it has to have an attribute called query that is a string, and an attribute called parameters that is a string array. Yeah, right. That's a brief look at what it looks like. All right, so the next topic is azu.js. So as you might recall, a couple slides back, I was showing you the Cosmos DB SDK for JavaScript, and it's great. It has some samples, has some documentation. I found that I wrote a lot of applications. I didn't want to write a lot of copy and paste code. I didn't want to refer back to all my other samples. And furthermore, I also found, I had to go looking through the SDK code to find what I was looking for in some cases. So therefore, I wrote this helper package called AZU.js. The name tries to imply AZU for Azure Utilities for JavaScript. So it handles some common PaaS services that I work with all the time. So Azure Cosmos DB NoSQL API is covered in AZU.js, Azure Blob Storage, Azure Cognitive Search, which is now called Azure AI Search, Azure OpenAI, right? So you can do AI functionality, create embeddings, etc. And also there's some primitive functionality in AZU.js just because it's so common. So file system operations, configuration, logging. Yeah, if you're a test-driven fan, so AZU.js utilizes unit tests that are implemented in the Jest framework. Really nice framework for testing. The library is here on NPM if you'd like to explore it. All right, so the real subject of this talk is this web application, right? So there's a demonstration web application that uses Cosmos DB, AZU.js, to implement a standard web application that uses Cosmos. Now, it provides a demonstration application for this Cosmos DB and TypeScript, but it's also I believe it's a good starter code base for developing your own app. So if you want to create a web application with TypeScript and Cosmos DB, I mean it's nothing more than like copying this repo and modifying it for your own needs. Also in this repo is a Docker file for building your own containers. If you're fond of using Docker Compose so that you can start and stop the containers on your local development machine, um, there are Compose scripts to do that. And lastly, in the AZ directory of the repo, there are scripts to use the Azure CLI command line interface program to actually deploy this container to an Azure Container Instance, ACI. So since I come from a Ruby on Rails programming background, so Rails has really a great set of code generators, scaffolding code, like starter code that quote unquote just works. So likewise, inspired by that, I just created this library a couple weeks ago, TSG.js, that likewise will generate some starter classes and unit tests based on Jest for you. All right. So for this presentation, this is I'm doing a screen recording of my desktop right now. So if you're watching this, this is not a live presentation. So for the ease of the recording, I'm just presenting the content of this PowerPoint. I'm not going to click in to the various code for you, but just as a roadmap for the code for your exploration. So there's a few entry points of code that are of interest for you. So index.ts is the entry point to the application using the Express Web Framework. So that is this file here. And actually it's index.ts. There's a Cosmos DB router. Express uses the concept of routers to handle certain HTTP endpoints. So this router handles the Cosmos DB endpoints in the application. That code is here. The HTML views are created with a templating language called EJS. And the views are here in this directory. Other files of note in the repo. So all Node.js projects use a file called package.json that defines the application, defines the npm dependencies. So for example, in the npm dependencies for this web application, the Cosmos DB SDK is referenced, as is Azure.js. For TypeScript applications, you'll see a file called tsconfig.json, and that specifies, as you might imply, and might assume, the configuration for the TSC compiler. Now, typically the two primary ones are, where's the source code and where does the output go to? So those are two entries in tsconfig. Last, there are two scripts for you to run this web app locally on your machine if you like. So both shell scripts, bash shell scripts for Mac or Linux, and PowerShell for Windows. All right. So as I just indicated, this is a recording. It's not a live demo. Typically, I would record this in a live session and show my browser. In this case, I've captured screenshots to show in the subsequent pages. However, what's really interesting, and what I ask you to do, if you'd like, is to actually deploy this container, right? So here's the Docker Hub image down here in the bottom. This is my account on Docker Hub. And you can use this AZCLI script, PowerShell script, to actually deploy this container to your Azure Container Instance and have it point to your Cosmos DB via environment variables that you set in the script. So literally, this web application is something you can deploy to your own environment in minutes. Alternatively, as indicated in the previous page, you can use Docker Compose to run this web application as a container. As this container, you can run it locally on your development workstation. Right. So let's finally take a look at what this web application looks like. So it's a multi-page application, uses Twitter Bootstrap for CSS. So here's the top navigation. These are some of the things you can do. You can log in, log off. You can set some environment variables to define who the valid variables are. Sorry. So this is the about page. It just describes this application pretty much as I've described in this presentation. Here are links to all the different technologies. So Node.js, TypeScript, Express, etc. Excuse me. Now, the next page is just displays the configuration for the application. So like most Docker applications, configuration is quote unquote injected into the application via environment variables. So this is the list of environment variables on the left side here that are required by this container. These names are my convention, by the way. They're not Microsoft specific, Microsoft required names. These just seem to be reasonable names for me. And so in the display, obviously for security reasons, like for example, if you have a key, then only like the first four characters of the key are displayed, not the entire key for security. But at the same time, it enables you to kind of look at this page to sanity check that you indeed have configured your application properly. All right, so this is the Cosmos DB metadata page. Now, what you need to do first in the application is, based on the previous page, right? You defined your Cosmos DB account and its key, right? These two variables here. So once you do that, this application needs to understand the metadata about your Cosmos DB account. That essentially means it needs to understand the databases and the list of containers that are in those databases in your account. It also gets information about the throughput of the container. So basically, what happened here is that you come in here to this page, you click the get account metadata, and then once you do so, this table appears with that extracted metadata. Now that metadata is used by these other Cosmos DB pages. So the next page will be the upload functionality. So basically, this is a drop-down list, this database and container combination. So this is a drop-down list, and this drop-down list is populated from the information, the metadata information extracted in the previous page, right? So that's where this list comes from. You get to choose a JSON file to be uploaded. Now, it's not just any old JSON file. It's a JSON array, and each element in the array must be a document. And furthermore, in the case of Cosmos, you need to each of those documents needs to contain the partition key attribute that you chose. So in this particular example, my dev database unit test container has the partition key attribute of /pk, meaning that the slash means it's at the root of the document, so pk. So you can select a file on your desktop. This repo contains a couple samples, by the way. There's a world airports file, and there's a baseball players file. It looks like in this case, I believe I uploaded the baseball players file, and it does. This actually does a bulk load, right? So when you upload that JSON, the web app will receive that JSON and then do a bulk loading operation to Cosmos DB with that data. There's a checkbox here to indicate whether you want whether you want the program to generate new ID values for each document. So that way you can upload the same data over and over and over again if you generate new IDs. You can do queries, of course. So Cosmos DB has the concept of reads or queries and point reads. Point reads are the most efficient thing you can do in Cosmos, but let me talk about queries first. So much like in the Azure portal that I showed earlier, you can specify a SQL statement. So we're going to select from the container, beginning at first document, returning up to 1 documents. I click submit, and lo and behold, I got this. So what's really interesting about the Cosmos DB SDK is that in addition to doing the operation itself, it returns some diagnostics for you. This is a very brief bit of diagnostics, but one of those is the request units. So this particular query consumed 2.28 request units. Now, to get the same data, alternatively, we could do a point read. And in terms of the user interface, this logic, if your form field begins with select, it's going to be interpreted as a select statement. However, if you just give it 2 tokens like this, this is the first one is the ID and the second one is the partition key. So that's how this particular web application handles that. So nonetheless, when you execute that point read, you'll see that it is quite a bit more efficient. It only consumed 1.05 RUs versus more than double that if you do it as a query. So just remember that point reads in Cosmos are really quite fast and efficient. You can certainly do CRUD operations, create upsert, delete. So this is just an example of, it starts with a sample document of the band U2, and it looks like I added myself as a member of U2. I clicked upsert, and the document was upserted. So again, this is just the demonstration that this application is just to help you understand and use Cosmos and see how it works. Another bit of interesting functionality in the application. So remember I said that AZUJS, mostly concerns itself with Cosmos DB. However, there's some blob storage functionality, and there's also Azure OpenAI functionality. So you can essentially enter in a prompt. So the prompt I entered was a watercolor painting of the planet Saturn, primarily light blue with yellow stars. Click submit. And so this request was sent off the OpenAI to the DALI SDK or API rather, that produces images based on a prompt. Alternatively, if you didn't click this, it would produce an embedding, basically to vectorize whatever your prompt was. So again, this is just kind of a demonstration page just to show you how to use Azure OpenAI with TypeScript. And of course, the Planet Saturn logo, this is intended to look like the Cosmos DB logo. Lastly, again, so another one of the integrations of AZUJS is with Azure Cognitive Search. It's now been renamed Azure AI Search because it has quite a bit of AI functionality in it now. So this allows you to enter a query. So it's a JSON-based query syntax. And you enter the query, click submit, you get your search results back. I include this in the presentation because Azure Cognitive Search really works well with Cosmos DB. Both of them work together very well. So there's some queries that are more efficiently done in a search engine, such as fuzzy string matching, and there's some like the point reads, that are much better done in Cosmos itself. So it's very typical for a real world application to use multiple services, not just Cosmos DB. Use Cognitive Search, use Synapse Link, etc. All right, so here we are. We are at the summary already. So in summary, so Cosmos DB is a very high performance, highly available, distributed JSON-based NoSQL database. Now, the thing is, it allows you to have low costs because you can provision the throughput to exactly whatever you need, right? So there's this. It's not like you you buy a database, first on a certain size VM, and that is created, and you use it to the best of your ability. Typically you're going to overpay in that kind of VM-based model. But with Cosmos, a throughput-based model, it enables you to essentially scale the database exactly according to your needs. TypeScript is a super high productivity programming language that transpiles to regular JavaScript. Cosmos DB has some really great SDKs. If you're fond of other languages, by the way, I encourage you to look at the .NET and Java SDKs in particular. Those have really great functionality. The SDK for JavaScript now includes asynchronous processing that's much more efficient than blocking. You might find this acjs package useful, both in terms of runtime code, but also if you're looking to understand how the Cosmos DB SDK works. Azure.js itself provides, I think, some pretty good code examples for you how to use the Cosmos DB SDK directly instead of using Azure.js. The choice, of course, is yours. Node.js is a super performant environment. It's great it starts up really fast. For example, compared to say a Java process, Node just starts up lightning fast. It's similar to Go in that regard. So it's very common to create microservices, Docker container microservices with Node.js. Yeah, Azure itself has multiple ways to deploy TypeScript, Kubernetes, Azure Container Apps, instances, etc. And this repo provides a really good starter app code base for you to freely take and use as necessary in your applications. And with that, I believe I will stop the presentation. And thank you for listening. My email and contact should be in the meeting notes here for this presentation. So please reach out to me. Please take a look at this repo as well as others here on GitHub. I'm glad to help you with Cosmos and to evangelize the use of Cosmos and Azure. Thank you very much.